I just want a bag, like an old lady.
Hello, I am back for more binary exploitation. Get started on that pretty quickly. I have only maybe 2 hours or so to work on stuff today, so we'll see how far I can get in this Facebook challenge. And yeah, I guess just a heads up before we get started. I might have to, go AFK in the middle of this for a little while. I have somebody that should be coming by to work on some stuff in my apartment, and I don't know what time of day they're going to show up. So it might just be during the stream, and then I'll have to go AFK for a little while, but hopefully not. So, first thing that we are going to work on is Facebook CTF 2019, a challenge called Overfloat. Should be similar, probably in the same vein as the previous challenges in this dynamic category, where we are going to use a ROP gadget to get to libc, or maybe just return to somewhere specifically in libc and not really do any specific gadgets. Yeah, okay, so I've already copied over the binary. If we look at it with file, it's a 64-bit ELF, dynamically linked, of course, not stripped. That's helpful. And then if we check the security settings on it, no canary, that's nice. NX is enabled, of course, for these. I mean, probably from here on out, NX is going to be enabled. So, going to do ROP if we have to. And then no PIE, so we can use gadgets from the binary itself and use addresses in general from the binary itself. It's only 14K, probably not that many gadgets in there. And we can just run it, see what it does. It prints out a hot air balloon, I guess, amongst a couple clouds. And then you provide it your latitude, the index 0. I assume if I type in words, it's going to complain. Okay. Huh. Okay. Interesting. So it was, I don't know if it's explicitly cycling or if it's only showing the last digit of whatever the index is, but it was just accepting input with no particular limits. So that's interesting. I could let's start at a more reasonable number than the 1024 that I've been doing. If I do that. Okay. It does result in a seg fault. So we got some kind of overflow, presumably. But we also got like a lot of prompts, which makes me wonder if there's a like a maximum for each. No, I think this is the same issue if you send in I'm just holding Control D at this point, so that is sending like end of file, whatever the read call is that they're doing, presumably is exiting without any input. And I guess if you do that enough times, you will get a seg fault. Oh, okay. Well, that was kind of dumb. So I hit that too long, and then the program quit with the seg fault, and I was still hitting Control D, and so I quit out of my terminal. So that's fun. Okay. All right. I guess I'm gonna look at it in Radar and try to figure out what that seg fault is coming from, because I wasn't providing input on each of those entries when we do like that. I clearly didn't provide input from the echo command that was so long that it overflowed a buffer, but we still got a seg fault. Either this is how to put it, either this is not the seg fault that we care about, maybe there's just another bug that crashes it, or it's not about the length of any of the particular inputs, it's about overflowing wherever this sequence of inputs gets stored, I guess. Presumably this stuff is being put in an array somewhere, maybe pointers to allocated memory, or something of that nature. I don't know. So we could look at it in Radar. I am curious if I can just overflow on a single input. So I'm going to print out a whole bunch of A's and then run the program directly, paste those in. That was long enough that it covered several inputs worth. So there's probably a read call with a maximum amount. So maybe there's a fixed size to each of these entries. And we got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 entries out of that. So if I do 100 instead, this should still overflow one of them. Yeah. Okay. But if we do maybe 50, that's too short. Maybe it's like 64. Right, okay. Let's do the shorter one first. That does not overflow. But if we do 65, does not overflow. Let's go over 80. Does not. 90. Does not. 99. That does. 94, let's start with. No. I guess 98, or maybe it's 99. We'll find out. So if we put in 99 characters, that is far enough that it reads, I guess, at least one of the characters. Like the read is only reading in 98 characters, and then this last one, the B in this case, is it prints it here because that's how the terminal is doing it, but that then gets skipped on the first read call because they give a specific number for the amount of bytes to read in. And then there's a second read call for the longitude input, and that will then get the B and new line indicating we're done with the read will then end with that one as well. So I guess each one of these entries is 98 bytes, and if we do this, we grep for lat or on. No, how do we want to do that? I want to see how many times it repeats through this stuff, because that'll be the number of entries that we have, I guess. Let me double check that it's the same. It's actually not necessarily the same number of times before we get a seg fault, which is interesting, because this one is ending on like latitude 8, and this one is ending on latitude 6, and this one is on, that one was latitude 6 again. This one is 6 and 4. So I don't know. I'm still a little perplexed as to what might be going on inside of the program that's causing the seg fault, and how it's storing the data that we send in. But if there's a fixed buffer for where, like, so if each of these entries can accept 98 bytes of input and store it as a string somewhere, then supposing they have allocated a fixed amount of space to store those strings, but they're looping through infinitely, eventually, even if you aren't sending input, each location in that array of places to store the input is still going to take up the same 98 bytes. So it'll just be all zeros, or at least it won't be written to. Maybe they'll write a 0 to the first byte indicating a empty string, but it's still going to take up 98 bytes. And so if you are just looping infinitely, moving on to the next 98 bytes, then maybe eventually you will overflow the buffer for the whole array of input buffers. Which, I mean, if that's what's happening, and there's this many, and the overflow is causing a seg fault, either, yeah, I mean, this is pretty, it's not long enough that we would have been overflowing from outside of the stack into the stack, I think. But then that means that all of this is on the stack, which is a pretty large amount of stuff. I guess what we could try is sending in okay. Does that do anything interesting? It's different amounts each time, which is wild to me. What could possibly be going on there? And so what I'm trying to do here is send a sequence of individual inputs. So the way read works, apparently, oh, you know what, that's probably just on the terminal. That's not going to help us. Okay, never mind. But if we do, let's say, so we send 98, and that'll be one entry. Does this do 100 entries? We do 1,000 entries. Yeah, it's still basically, I mean, I don't know about random, but it's not consistent where the seg fault is happening in terms of how many input prompts we are seeing. So I'm just going to go in the program in Radar and see. It said it was not stripped. It did say that, right? Did I run the wrong? No, okay. Looking at the right binary. It says not stripped. So what is the... I was looking at Ash Fox's stream and he was going through some, I think he was watching a Live Overflow video where Live Overflow was talking about Radar and commands for it, and there's a better command than the way that I've been looking at for like the names of all the functions. So I'm trying to find what that is again, because I can... Radar commands just completely fall out of my brain. No, it was like PFL, I think? PF? Which is... They have PFL? It's not a thing. Okay. Well, let's look it up. The intro. Is there an FL? F seems to all be flag stuff. And obviously the functions that it has found... Oh, you know what? I just didn't do any analysis, maybe. Okay. No. Okay. So... AFL, list all functions. I see, like, the organization there is, I don't know. I don't understand why it's under analyze. But okay, maybe I'll remember that because there is the fuzzing tool called AFL, and I'll just try to remember that. We have entry 0, and we have main. Okay, so I just have to go to sim main. For whatever reason, it didn't call it main this time, or maybe the issue was I hadn't done the analysis the first time through. That seems more likely. Okay. Ooh. That's truly helpful. Yeah, I mean this... Trying to think if this is like worth me trying to get a patch in of just, hey, maybe we should have a limit on either the name of the flag that we create for a string, if that just turns out to be a really long string. Maybe don't create a flag that's like hundreds and hundreds of characters long, or create the flag with that name if you so wish, and just don't show the entire name in the visual mode, because starting in the middle of this thing and having it go as long as it has, like, really unhelpful, I would say. This is not a helpful interface situation that we're in. Okay, so, but it's not going to hinder us because we just scroll over and let's see. So we call memset with RDI is this buffer at RBP minus 30 hex. I guess 3 is like the C functions. So this is the buffer that we are setting memset to. The byte is 0 and the size is 28. So we are skipping 8. Is that a reasonable understanding? I think so. I think the last 8 bytes of this buffer are just not being done anything with by the memset. And then we pass it in as the parameter to this chart course function. Okay. And I think this is setting up the alarm signal, so we have to do whatever we're going to do with it fast enough to beat that alarm, which is 1E, so what, 31 seconds? Or 30 seconds, rather. Okay. Let's see what the chart course function is, because that's going to be the one that takes all of our inputs. Okay. What are we doing in these two sequences of moves and shifts and multiplies? This is, oh, you know what? I've seen this in most recently I saw it in another project that I was reverse engineering, not on stream or anything. And this is just the sort of stuff that comes out when you have a compiler optimization that optimizes an integer division. So basically they're taking the length of whatever the buffer is and they're dividing it by a certain amount to get the number of entries in that. So let's say you have a buffer of integers and you've made it 40 bytes long, and you know that your integers are 4 bytes, then in order to figure out how many entries are in that buffer, you can divide 40 by 4, but doing a division instruction is not, is not as performant as maybe doing a whole sequence of simpler instructions with add and maybe multiply and stuff of that nature. So in like maybe 40 divided by 4 is not really going to come, like that would probably be a much shorter sequence if it had to do that. And obviously you would only generate this set of instructions if you didn't know that it was 40 that you were actually dividing by. If you know the divisor but not the, I don't remember the right math terms, but in the case of the 40 byte buffer, if you didn't know the length of the buffer but you knew the size of each element, then you could generate this set of instructions to calculate the number of entries in that buffer at runtime. So that's what we're doing here. I don't know what this works out to, but we could certainly like put a breakpoint after, I guess on this instruction, and then I think ESI is going to have the result of that division in there, and maybe that will become useful later on. But once we get, so this is just printing out and it's giving us a single, this might also be dividing by 10 in addition or something, so that we are getting just that last digit. Or maybe it's taking a single number and dividing it by 10. That could be like, maybe we're not doing a number of entries in an array kind of thing, but instead we are looking at it and going, okay, this is the number of the entry, like we are on the 57th entry or something, but we're just going to display ln 7. So we are dividing that. So this was like, actually it was more doing modulo. Divide by 10 and get the remainder in that case. So modulo 10 or something. And yeah, okay. So presumably local 4 is where we are storing the is where we're storing the like the index number for the entry that we are currently putting in. And we call fgets. Interesting. Oops, I meant to go up here. Okay, so we have a stack buffer that's at RBP minus 70 hex, and we're doing fgets with a length of 64 hex. That's fine in theory. Yeah, that should be okay, because we should have 68 bytes worth, since the next one is at RBP minus 8x. We should be able to store actually 68 hex bytes of data into that buffer, I think. And then what are we doing? Oh, so if you type in done, that's the end of the program, where it's just like telling the program that you have no more input to give. So that is good to know. Okay. Otherwise, we attempt to convert it into a number, into a floating point number, and what are we mem setting? And then we reset that full input buffer to 0. Okay. Guess that's reasonable. You could probably code it to be safe and not need to do that, but it doesn't matter. And we store that input result at local H. We think this converts dword to quad. So it's just promoting EAX maybe to RAX. And then times 4. So this is us storing the floating point value, because it looks like we are doing just a 4-byte value, because this is the index number times 4, and we add it to the beginning of our buffer where we store the floats. So those floats get stored into the buffer at local 78, or No, 78 points to that buffer. So where does that buffer come from? It's from RDI. So if we go back to this one, we have an RDI is the first parameter, right? So it is this stack buffer from the main function, which has a length of 30 hex before we get to RBP. So 30 hex divided by 4 is going to be 12 or 120 rather. You get four byte chunks in every 16. No, it should just be 12 entries for 30 hex, right? Yeah. So that's interesting because I guess after 12 entries, it overflows. Let's do I think the difficulty here is we're storing floats into that buffer, and so we need to figure out the float that has the IEEE 3 whatever the like floating point standard is, has the bit representation that we need for our ROP chain elements that we're going to put in when we do the overflow. That is the tricky part in this one. Okay. So okay. So I've got some test input that should provide 12 entries. I don't think this will I think only after 12 entries does it overflow. That's my guess. So we'll see, this should work. Okay, no seg fault. Then if we do another 2 entries, because they're 4 bytes each, that's going to hit I should double check, but I think it doesn't matter if we're doing latitude or longitude, but I'll have to look in the chart course function again. So if we do another 2, that'll be 8 bytes that'll do the RBP, and then after that, that'll overwrite RBP that was pushed on the stack, and another 2 beyond that, so a total of 16, will overwrite the return pointer. So this should get us a seg fault. Yeah, okay. Whereas I think 14 would not, because it just overwrites RBP on the stack, and probably the old value of RBP isn't that important to the program quitting. Okay, so we know how to trigger our seg fault and what we need to do to accomplish our ROP chain and all of that. We don't have I don't see where we would necessarily have an info leak. in like where we could get the addresses, some kind of address in libc. We could do the thing that they did in the write-up of the previous challenge, which was to put the address of the call to puts. So they did some stuff with the global offset table and the procedure linkage table, and basically they returned to the PLT stub for puts, having pushed the address of the global offset table entry for puts into RDI, and that allowed, and then puts is going to print out the address that is inside of that global offset table entry, which is the location of puts as it's been loaded by the kernel loader at, at its randomly based address, basically. So that's our leak. I guess we'll have to do it that way. Maybe there's something simpler that I've failed to see, but it didn't look like there was any way to like easily make this program print out the a pointer to something. So I think we'll go for that. And then their approach was to also then put the start address of main as the next thing to return to after having it print out the string of that address. So yeah, and then they go back to main, so we start over again, and then we have the info that we need to actually accomplish our ROP chain with the appropriate gadgets and stuff. Okay. So I might have to look back at the walkthrough to see how they did that with Pwn Tools. They loaded up the ELF and then looked for the put symbol in there. So they loaded up the ELF of the actual binary. This is the one of the ROP gadgets that they're going to need eventually. This is the address of the global offset table entry for that. How did they find that? Okay, they did it also with Pwn Tools. So I don't know why they didn't just call that inside of the Pwn Tool script, but that's fine, whatever. So yeah, they call ELF symbols for puts. That gives them the PLT stub address. Then they call elf.got for puts, and that gives them the offset table entry address. Okay, so far reasonable. And then they use GDB to work out the offset of puts and system and whatever they need inside of libc. Okay, right. So this is the stuff that we could probably manage with the one gadget approach. We would need to ensure that some particular location on the stack had a null value, which, I mean, I think the binary representation of a floating point number that is 0 is still just 0 for convenience sake, but I could be wrong on that. Is it 354 maybe? What is the actual 754? Okay. Is this that website that I'm remembering? It will probably serve, but I don't think it's the one that I was thinking of. So yeah, if we have 0, then the binary representation is 0. If we have 1, it starts to get a little more involved where I guess this is, oops, no, don't do that. No. This is the mantissa, I guess. This is the exponent? I don't know. I don't know why there's so many why there are so many ones needed for that, but I'm not going to worry about how this works at the moment. I think it would probably be a good idea to, you know, maybe write my own tool to like take a floating point number and convert it into a legit floating point, like take it as a string and then convert it so that I end up with a full understanding of the encoding form for the IEEE 754, but I don't need to do that for this challenge for sure. So I am going to, you know, we might just do all of these things manually. Maybe there's a way to unpack a float basically. Interesting for leaking memory. Packing and unpacking of strings. So it would be very interesting if we could unpack a float with pwn tools, but I don't know that it has that capability. Search for a float, or does it say pwn tools does not? Oh, it does not support Windows. Okay, I didn't. So I think I'm just going to do it manually. If we had, this is a write-up of something. Okay, I'm not going to read the write-up of a thing on pwnable KR because I will hopefully want to do that at some point in the future. I like the little art that they have for all of their challenges. Yeah, so in order to come up with a working ROP chain situation, we need to be able to take the binary representation of what we want to have in the overflow data and put that into this website. I think maybe I can just throw the hexadecimal in there. And we'll have to think about whether or not this is little endian or big endian. To figure that out for sure. And then, well, I guess one thing we could do, right, is to figure that out. I'll do that in a second, but just continuing on the explanation of how we're going to achieve this. Once I know what the hexadecimal representation of, say, the return address for one of our gadgets is, I'll throw that in here. Fingers crossed, it tells us an entry value. I don't even know if I can, like, can I do it this way? Yeah. So this maybe is what we can enter. And that's why we've got that gigantic buffer that's got like up to 64 hex bytes of input for the converting to a float, I think, because we might need a whole lot of precision to get the exact byte sequence or bit sequence for the actual representation in memory. So we'll throw in the hex that we want. It'll come out with the value that we need for the float, and then that's what we will actually pass to we'll pass this as a string to the program. It will do the reverse conversion, end up with the hexadecimal or binary representation that we want, store that in memory. When we get to the overflow, it'll have the right value. So that's the strategy, but I still need to figure out if we can take the values that we have directly in, like what we're going to get from calling ROP gadget or whatever, and throw them in here, or some particular address, let's say, and whether that will be the number that we anticipate it will be. I feel like I need to figure out if we need to do some conversion for endianness. Let's simplify it. Okay. So what I can do is just run the program in GDB, not like that. And then I'm going to put in 1 as the entry. Then we'll break, and I want to put my breakpoint, I don't know, after where are we storing it? Store it here. So chart course plus 301. And continue the program. Okay, well, we still got there. So need to look at not what's in XMM0. Oh, you know what? Let me run it again, and then we'll hit this. Okay, so now what is in XMM0? I don't know how to get it to show me those registers, but if we step 1, I could probably look at what is in racks, which is 3D0. Oh yeah, okay. So we end up with this. And yeah, so these are the high bytes, I guess. Let me copy this and then we can do it that way. Okay, so it's actually just the first 4 because we're working with a D word anyways. So yeah, that is fine. We don't need any conversion because these will be the high bytes. Okay. That works for me. Then let's do one gadget. What is overflow? Link to this libc file, and we can do one gadget in that file, and this will give us the offset. I'm going to use this one again, where the constraint in order to use this gadget is that RSP plus 40 hex must be null, and what do we store in local 40? Do we use local 40? Oh, it gets RSI. So maybe this won't work for us, because when we get to this ret, like RSP is going to RSP plus 40, I think, is going to point at, oh no, I'm doing the order of stuff wrong. It's going to point back into this buffer. So maybe just the first entry into there needs to be 0. Let's try that. I think we can see this in GDB. So I'm going to enter 0 for the first. Hello again. Yeah, my OBS crashed. I'm just going to vamp a little bit until I can see that the stream has come back online and the bitrate has returned to a reasonable amount. I don't know how much was lost because of the delay and all of that. So I'll go over that stuff again in just a few seconds when Twitch Stream Manager says that the bitrate is reasonable. It's still red, even though OBS is like, you are streaming at 2700 kilobits per second. Maybe it just takes a little while on Twitch's side for it to figure out that the bitrate has gone back up to a reasonable amount. Yeah, just kind of vamping a little bit to know what the situation is with that. So, okay, we will. Yeah, Twitch is seeing it. I don't know why it's still red, but I will ignore that for now. It is seeing the actual bitrate that I have. So, okay. Explaining again what I'm looking at right now. I used the one gadget script, which is a really handy script to find a single location we can return to, which will do the shell popping stuff that is ultimately part of the system libc function. The libc function for system has an implementation that basically calls execve and passes in /bin/sh. So we could set up several gadgets to use the parts of the system function to make that call ourselves, but this one gadget thing finds a location that we could just jump to within the system function, and it will take care of everything for us by the fact that we jump to that specific address, which is great. But there is a constraint that we have, which is the second parameter to the execve call is going to be RSP plus 40 hex, because that's just how the code is written at that location, and we're reusing their code. So the constraint is RSP plus 40 hex should be a null pointer. It should be 8 bytes of zeros. So we need to be able to control that, because otherwise, if it's gibberish data or it's something wrong, the execve call is not going to work as we want it to. And then I was looking at what the stack would look like on the main function at the time that we return to this gadget, and I think the situation is that the very first entry, which is at RBP minus 30 up through RSP, or rather up through RBP minus 0, and since RBP is at RSP plus 40, then RSP plus 40 is going to be the first entry in our buffer. So we can put zeros for the first 2 entries in the buffer. They're 4 bytes each, so that would be 8 bytes of zeros, and therefore RSP plus 40 hex will equal null. I'm going to check that just by running it in GDB, putting a breakpoint on the return, and right before we return, I can look at the value of RSP plus 40 hex, see what that is. And if I'm right, then that's a pretty simple thing. We just make sure that the first 2 entries into the program, the first 2 inputs are 0. So run that, disassemble main, put our breakpoint at main plus 140, run the program, 0, 0, done. Okay. And now we want to look at RSP. Why do I always miss it? Okay. So we want to look at one giant at this address plus 40. Nope. Okay. Because where is our zeros then? Interesting. Is that where the zeros start? I guess so. So we don't have control over RSP plus 40. What is RSP plus 70? RSP plus 70 is 0 by happenstance. So RSP is 7 series of Fs, E408. So if I look at E478, that's plus 70 hex. And that has a value of 0 as a giant, which is an 8-byte value. So I think we can just use that gadget instead. So one gadget also found a version where the constraint was RSP plus 70 hex had to be null. So we'll use this gadget, and then we'll be good. We can start writing our exploit. Put the constraint in here just so we remember what that is. And we also need to look at the binary. We need to load it as an ELF so that we can get the puts PLT entry and GOT entry, which is, what do we call it? Overfloat. Okay. I think it's let's do this first. Double check what I'm trying to do is correct. Dot dict object is not callable. How did they write? What was the syntax they used in the other one? Up here. They just call it elf, and then elf dot symbols and elf dot got. Oh, I put parens instead of okay, so we get the addresses for those. Then we need to leak the address of puts in libc and use that to calculate the base address of libc. So do I need to use GDB or can I find it in what do I want to do? Can I just do like okay, so this is the offset from the base address of libc for the puts function. And I'm going to, I know there's a way to like quickly change the case on that stuff, but I'm not going to worry about it. Is there a good reason to put these things as, I'm going to just do everything lowercase. I'm sort of in the like mindset of a C programmer where I'll use uppercase for constant values because that's what you usually do with a like macro definition, but it doesn't necessarily fit very well in Python. It makes a little more sense in Ruby where actually starting with a capital letter makes something a constant by language semantics, but we're going to set that aside. Okay, so once we leak the address that shows up in the global offset table entry for puts, we can take that address, subtract this amount from it, and that'll give us the base address of libc wherever it was loaded. So the first thing we need to do is run the program in such a way that we can overflow the buffer and put in the right gadget and all that. We also need to pop into RDI. So we've got a pop RDI gadget that we can throw in there. However, this is what we need as the binary representation. Yeah. So we actually need to figure out what the floating point number representation as a string should be for this. Why doesn't it? I think maybe I need, let's see. Got too many. Yeah. Which is this gigantic number. Okay. So I don't know if I can put that into like, do I need the E39? I think I do. Let's find out if it works. Okay. It's so long, and then it is still in exponential notation. I have no idea if A2F is going to parse that properly or what. So then we also need to say we need to get this number. Yeah, my plan of like, oh, let me just what should I call it? Let me just grab these and use them directly. It's not going to work because I need to first pass them manually through this thing, unless I decide to write a bit of Python code to do the conversion for me, and I don't want to think about that right now. So we are going to print the hex of puts PLT and GOT, and then we're going to exit because I don't need to do any of the rest of it for now. Well, that's fun. What did I do wrong here? I left something. Okay. So first thing, so we will do this one. No. Okay. Fun. Why don't you actually copy? And then 4 zeros first. That's this thing. Binary is that value. And then, oh, that was the PLT though. That's this one, okay. E39, e to the negative 39. Okay, so we've got the numbers that we need to put in there. And the PLT address, both of these addresses need to be, actually, sorry, all of them just need to be prefixed with 0. So I'm going to leave off the 0 because we know that we're going to prefix them with 0. Prefix? Postfix them with 0. Yeah. All right. Then we are going to run the program, and not going to care about putting the zeros first. Oh, that didn't matter anyways. So I guess I'll just put zeros because it doesn't really matter what we are filling the buffer with. So we're going to do prefix entries is 14 entries. And for I in range prefix entries, we're going to receive until, I think it's that, and a space. Then we will send line 0. So just fill up all the entries with 0. And now we can start overriding the return pointer. So we'll overwrite with our pop RDI gadget first. So even now till that, and we'll send line with, let's make a little function. We can do it up here, I guess. Def. Of course, we need the target in there as well. I can call it target just for consistency's sake. Why don't we do, yeah, we'll do it this way. Okay. I think that's fine. Do we ever need to send a 32-bit? I think I'm going to say send 64-bit. We'll send a 64-bit value, which we'll do first. Send val no, first we send. Okay. This is just incredibly hacky. And certainly, wouldn't work for every circumstance. But if we know that the upper 4 bytes of our 64-bit value are going to be 0, then we can just send a straight 0 rather than calculate what those upper 64 bytes are actually going to be. Because in order to calculate that programmatically, we would still need to be able to calculate what these floating point string values are and stuff. So we're just going to do this hacky thing. And for this, we're going to say send val 0. We could do 7 entries or loop through this 7 times and send a 64-bit value of 0, but I don't care. And then we will do send 64. Do need to say target. Send 64 target pop RDIF. Send 64 puts GOTF. So this will pop GOT entry address into RDI. And then we will say puts PLT, so we'll call the PLT entry and then we will target.send line done. We'll receive everything just to see what happens. It's probably not going to work because I have a exit up there. Okay. Why is it not? Where's the longitude? What went wrong here? We aren't sending zeros as we thought we were. I mean, I'm going to take off the stir just because I know it doesn't matter. But I don't think that has anything to do with this issue. So we should be sending 0. $14 times. This one doesn't like. I guess it does it care about. Can we print this and then we'll see what it's outputting as we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Am I counting too quickly? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then our gadget, GOT address, PLT address. So what are these about? I thought then I typed in done. Done should quit out of things. So why is it not? What happens? We don't receive a line from that. Weird. I would think that after sending the 0, Is it not like one of these for some reason? It does seem to seems to accept the pop RDI, which is the longest of them. So what if we send the done after that just to see where things end up? And then we get to where's the longitude? As in, we need to send another value. I see. Okay. So we somehow have ended on, I don't understand, right? Because we are doing 14 entries, so 1, 2, 3, 4, 5, 6, 7. The first 7. Then we send our 2 entries for the ROP gadget. And then we hit done. Do we need to hit done twice? Like, right, okay. But if we do 1, 2, done. So why, yeah, why did we switch to like immediately to latitude 8? So should be doing everything in pairs. I mean, we could try just doing it twice. It's not that. But yeah, it doesn't. All right, let me try directly sending one of these strings. That is too long. Okay. So what if we simply truncate it and take off how many digits? 20 digits in this case? See if that works. I need to throw it back in that conversion tool and see if we get the exact same bit sequence, or if I have messed it up. I just reload and I can. Why does that not work? Oh, maybe I should have been copying the first value from that site. So we want this binary value. And maybe this is the one that we need to put in. I thought that was going to be too inaccurate, but it does give us that exact. Okay. That's a lot nicer. So the reason we were getting that, like, it was not expecting us to type done is because that's the it had read multiple inputs because our thing was way too long. So, okay. Our representation of the floating point value was the actual thing, which is not the same as what you want to enter into the program to generate that bit sequence. And that actual representation, where they sort of have the, like, this is what it really truly exactly means, even though you don't have enough bits to really represent that, that was a string that was too long for a single entry value. So let's see if it will accept this stuff. And then really I should be able to say like, if it's ending the program then. Okay, so we get Bon Voyage, and then we've got what is presumably the address. We read everything until the /n, I suppose. We've got 1, 2, 3, 4, 5, 6 bytes. Why do we not have more bytes than that? I guess it's all zeros before then. Yeah. And then 2 bytes of zeros, and the /n just gets thrown in by puts. Okay. So we want to receive until Bon Voyage /n. And then we want to do we need what we'll find out. Let me say drop equals true because we don't want the /n in there. And we can unpack that as a 64-bit value. Make sure that actually prints properly. And then has to be 8 bytes. Okay. So just do _s for the string version. And we will say libc puts adder s plus equals /0 times 8 minus, I don't need this open paren really, the length of libc puts adder s. So we'll pad that out to 8 with null bytes, and then libc puts adder is equal to unpack 64-bit value from the string. Can't concat string to bytes. Right. I don't want to decode it though, because who knows what that looks like in can we do this? String object cannot be interpreted as an integer in the, no. go with that first. So print out with the null bytes in there, that's fine. And we unpack it. Oh, because we don't need the rep. Yeah, that's fine. Okay, so that's our address of the libc. And now libc base is equal to libc puts adder minus libc puts offset. And we know where we can do our gadget. So we're so close now. We want to get the address of main. And that's going to be some floating point string. So now our original ROP chain should also have the main address. So we will restart the cycle after we have leaked the pointer to puts. Because we need to now repeat the process, and this time to pop the shell. So we will do our prefix entries, and then we're just going to send the one gadget. And I'm gonna say underscore F on all of these. Let's throw this one down here. So then this one we'll get the floating point out of as well. Got it. Okay. And then on the next iteration, we just need to send that single gadget. That'll get us to the shell. Yeah, feel okay about that. Let's give it a shot. No. All right. Well, I want to. Let me see. Is there anything obvious? No. Okay. Got segfault instead. Do we need to pop stuff? We're not doing the system call, so I don't think it's the stack issue. That's not what I wanted to do. Okay. So what might we? Oh, I don't want one gadget that way. Oh, this is gonna be okay. The thing that I was hoping to avoid is unavoidable. We need to figure out the floating point value for the one gadget address. And the one gadget address, we don't know the actual address until we've combined it with the leaked libc base pointer or base address. So we do need to programmatically create this entry, like the string float representation. So Python struct, let's see if we can unpack a float. Yes. So we can unpack a float, and then maybe we can do repr on it. So let's say we take pop RDI as binary. Oops. And we call we'll just call it _f for now. This code is temporary just to check that my understanding is right, and we'll delete it. So I'm going to reuse that variable name for now. Struct.unpack, and we know we want it as little endian, I guess. An A and unpack. And then I'm going to say print repr of pop rdif and exit. Byte-like object is required, not int. Can I do struct dot unpack little endian? What is the D word? Just capital I for that, I guess. Oops. Well, even that, okay. I need to pack it, is what I need to do here. Okay, and that gives us this string. I don't know why it's a tuple there. Something to look at, I guess, because I might need to deal with that type difference, but how do these differ? It's slightly longer, but not so long that it would be a problem. So, okay. I think we can use that then. I call type on it. It is a tuple. Interesting. What we get back from unpack is a tuple? Yeah, okay. But why? What would the second value in the tuple be if it wasn't just a single value coming back? I'm not going to worry about it because we know it's the first value. So let's go ahead and make a function to do this. As float, I guess. I mean, maybe there's functions for this built into Python. It just doesn't seem like the kind of thing that they would want to do. Just like reinterpret this binary. Like reinterpret an integer as a float. And not the same integer, but as the bit sequence for a float. Okay, so we'll take an integer and we will say return unpack that, I guess. We don't need this one. And like, we can just say in fact, we don't need these at all because we're getting them already from up here. So I'm fine with all that. Oops. And okay. Is there better organization for this stuff? Let's do it that way. Sure. Okay, so now I want to take as float n so now we can do the right thing. It shouldn't matter because I think all of our values still have 0 for the top 4 bytes, but our thing should be a little nicer now. Just why not? I'm gonna do it that way. Let's do 7 entries, and we'll send a 64-bit. This way we're just making use of the calls to asFloat that are already written up there, but they'll just be zeros. Okay, and then here, take off the _f. Still getting that. And then libc gadget equals libc base plus libc gadget offset. Right. Changed so much that there's a fair chance this fails. Just have to give it a shot and see what doesn't work. Float has no attribute in code being called, we call send line from, need to call repper on these. And it worked, sweet. So, I mean, I spent a little while trying to avoid writing what turned out to be a very small amount of Python and instead going through this manual tool. And I should have just sucked it up, or at least like thought far enough ahead to realize that I couldn't possibly avoid doing it programmatically because I needed to calculate an address at runtime and then convert that into a float to do the necessary work, or to actually get the gadget to go. But otherwise, this is pretty good. I was able to use the technique that they talked about in the walkthrough for the previous one. I was able to work out the puts address as loaded in with libc to get the base address from libc by doing their trick with the GOT and PLT. So that all feels pretty good. I feel good about this one. That it's continuing in this theme of like I kind of feel like I'm getting the hang of it. This one took about 2 hours, and a lot of that was just working through the how to put it, the float stuff. So yeah, I'm all right with that. I think since it has not taken too long, let's see, we're at 1:30. Do I want to take a stab at the next one? I guess I'll give it a shot. I'm going to take a break for a minute or two, and then we will continue on with that. I've really only got like an hour before I got to end the stream. So I think there's a fair chance that I won't be able to get through this one in time on this stream, but I'm going to start with it, and with any luck, I'll be able to just go into the format string ones on the next streams. Fernicarol69, I don't know if I'm pronouncing that right, but hello, welcome to the stream. You've joined just as I'm about to take a break for a couple minutes, but you're welcome to hang around and see if I can solve this pwnable challenge from the nightmare course of just a whole bunch of pwnable CTF challenges. So threw that in chat for you. If you haven't seen this before, check it out. There's several dozen of these challenges in the list. Each of these entries is another different CTF challenge from mostly in the last 4-5 years. There's probably a couple. I saw one that said HitCon 2014, so there's a few that are a bit older, but most of them are like 2017 and later. So decent challenges. All that I've been doing thus far is stack buffer, buffer overflows on the stack. The last few have required doing, I guess, since they introduced or talked about NX depth protection or that mitigation, these have all been like ROP based stuff, and this is the first ROP stuff that I've been doing, but it's been getting a fair bit easier. You are learning heap stuff currently, and it's giving you hit kicks. Yeah, I mean, that doesn't come in till quite a bit later, but I'm excited for it because when I go like hear about the stuff that people are doing in like pwn to own and just generally seeing like CVEs and write-ups of real world bugs, it's almost always a heap kind of thing. So I'm excited to try that stuff because it feels more applicable to the real world than, hopefully by now a lot of these stack overflow issues have been eliminated from at least, the most juicy targets, as it were. But I also am a little scared because I think I'll be in the same boat as you of like trying to wrap my head around it. Even the concept, understanding the concept makes me like wary of how doable that is. Obviously it's doable because people make real exploits from it, on a fairly regular basis. But yeah, I'm excited and scared at the same time to get to that. But I've got a few pieces before. I'm just going to try to go through this in order. I don't know that, this stuff really is going to make it easier to do the heap stuff, but the more practice I have before I get there, I guess the better chance I'll have of like being in the right headspace and having all my tools dialed in, so to speak. So yeah, but I'll start to feel like I can really tackle almost anything if I can get through these heap exploit challenges. And then probably my goal is from here move on to like pwnables.kr and some of the other sites with tons of challenges. But I want to get into like looking for a CVE or something and try to recreate, or a write-up of what somebody did for pwn to own, for example, and just actually recreate their exploit on real world software and start to get that sense. And then eventually move into, I guess I have to, really get good at fuzzing in order to be able to actually find the vulnerabilities and later, create exploits for them or proof of concept or whatever, so that I can do the responsible disclosure thing and get a CVE, and who knows from there. That's all well down the line. So for now, I'm going to concentrate on this next CTF challenge, and I'll be back in a minute or two if you want to hang around and watch me give it a shot.
I got scales all on my floor. I got money on the line, plus I'm clocking it below. I got bitches kissing bitches, all them bitches go explore. I'm feeling way up, I stay up. Put your bitch on my Snapchat while I make her. She want a chance with me, cause she know I'm a rapper. I give a but I never get feelings, cause shawty, I know what you after. Okay, they watching me, they watching me, they watching me. They watching me, they watching me, they watching me. They watching me, they watching me, they watching me. They watching me, they watching me, they watching me. and 12, gon' find your ass way in New Orleans. Watch I look, I'm jugging. Dissect your hand if your hand in my putting. Put two in your man if your man keep a looking. Act like a poop, your bitch get tookin'. I'm not the type to go fuck with them niggas who fuck with them niggas who stay on some fish. Oh, young and trapping out the bando. From the ceiling fan to the damn floor. Trying to stack my money up. Cause that's the only way we can go. Tell my mama that I'm okay. See the money coming through the doorway. Got a bad bitch with a lot of money, that's foreplay. Okay, they watching me, they watching me, they watching me. They watching me, they watching me, they watching me. They watching me, they watching me, they watching me. They watching me, they watching me, they watching me.
Cause I don't want nobody to change me now. Cause I like to be myself. If you're not agree, you can walk away. You can walk away. You can walk away. Something in my mind makes me think I ain't nobody perfect. Something in my mind makes me think I ain't nobody perfect.
Alright, we're back. So, I'm going to work on this. I did end up, last stream I was wondering to myself, as I was looking forward to what challenges I was going to work on the next stream, I was wondering to myself, what is HS 2019? Is that the high school CTF? I didn't think they would have a bunch of ponables, but apparently, you know, they have more advanced challenges in the high school CTF than I was expecting, because this is definitely one of the ones from their 2019 CTF. So that's cool. I found a write-up separate from the one that's here in this course, and I might take a look at it after I'm done. But yeah, we're just gonna dive into it. Need to copy, need to get out of the stuff that I'm in right now. And copy that. Okay. Copy the file from the original repo. And let's look at it. It's a 64-bit binary dynamically linked, because that's the section that we're in. These challenges are further subcategorized. They don't actually mention the categories, but the directory names all sort of indicate which subcategory they're in. So we are in the buffer overflow dynamic. So these are all dynamically linked binaries with a buffer overflow. They've all had like NX bit on, because I think if you're doing, you can just put your shellcode on the stack and execute it, then it doesn't really matter if it's statically or dynamically linked. You're probably going to take the same approach either way. Symbols are not stripped, so that is handy. Check the security of it. And yep, NX is enabled. No canaries, that's nice. No PIE, so we can take advantage of addresses from the binary itself without needing to leak anything. Let's just run it. Okay, HSCTF pwn, tell me a story. Hello world. Okay, so we enter one thing and then the program exits. So I have a feeling that we know where to put the input that overflows a buffer. We can start trying to see how big that buffer is. Let's start at 512 instead of the usual 1024. Okay, that's seg faulted. Cool. 256, also seg faults. 128, also seg faults. That also seg faults. Interesting. That does not. Oops. That does not. What do we do? 56 maybe? It's 8 plus 8. Okay. And 55. Okay, so at 56 bytes, then we get a seg fault. Yeah, we could do the pattern create. I don't know why I don't like go through using the De Bruijn sequence pattern stuff very often, but I don't know. I should probably get used to that process more than just, doing it manually, because I don't even know necessarily if, yeah, let's give it a shot. I think Pwn Tools has a pattern thing. I have, somebody was mentioning it on something cyclic, that's what it is. I was watching, do you know John Hammond? He does a lot of like pen testing, CTF stuff, and he had a video that he uploaded yesterday, I think, or maybe this morning, depends on what time zone you're in, where he worked on a little box on TryHackMe which had a pwnable towards the end of it, and he used pwn cyclic, which I hadn't. Let's do 60 bytes, or this was 64-bit, so let's do 64 bytes because that should be enough. What do I need? LO. Oh, not N for the, okay. And so he used this tool, and then I didn't realize that Pwn Tools had one. I know that Radar has one, I guess GDB PETA. I'm using Jeff because that's sort of what was recommended at the beginning of this course. But, everybody, and Metasploit has one as well. You can enter the binary in GDB and pattern create 70, and I think it's better than Pwn because you can see the registers. Yeah, I mean, definitely, like, you're going to get more info if you are looking at it inside of GDB. But I think I'm going to try the process that he used, which was, I guess we can do this. Do this, get the seg fault, and then demessage will say where it seg faulted. This is the IP address. Not IP address, but like instruction pointer value. But that only, I think, like this isn't part of the sequence, the 7F and all that. So That is interesting. Yeah, I mean, maybe I should just use it in Jeff. Because I don't think that I am writing further. Oh, I'm looking at the wrong thing. Where do we get a... I don't know why we only got one of these lines about segfault. This is the /n. Oh, probably because when we overrode it with just 1 byte for the /n, which was maybe the 56, that went to a valid address and then got a segfault from some instruction accessing memory that wasn't valid at that point, rather than these are going to that address. But that's the same address every time. So, okay, let's just throw it in GDB. And you say pattern create. Oh, okay, just no underscore in the Jeff version, I guess. So how should I be, like, I'm just not familiar with how to go through in this process. And I can run it with echo this text. Why did that come out? Oh, because I didn't copy it properly. Run the binary and then... Okay, I'll just run it. Yeah, that's fine. Okay, so I got segfault on the return. RSP is this. Okay. So then pattern search for that and at 56. Okay. So starting at byte 56 is where I'm curious why 55 as input didn't, I guess whatever function they're calling to read input doesn't include the /n. Or, well, I was doing Python print, so there is no /n with that. So, okay, but it doesn't write a null byte at the end of whatever. It's not like gets or something. So, okay. That's all good. Cool. Yeah, I'll use that next time. That seems pretty straightforward. So, I mean, is this all that, if this is everything that we need to do, then I could probably get this done in a, hopefully in a pretty quick manner. What I want to do is get the one gadget. You know what, let me get that crash again. Oh, that's not what I wanted. Run the whole thing, get the crash. And then let's look. Oh, you know what? I don't want it to crash. I want it the normal behavior. So let's break on main plus 110. Run it normally, and now RSP plus 40 is 43. No, 42. That is a certain value. Okay, so RSP plus 70 hex is null, meaning we can use the one gadget that we used on the last challenge, which has that constraint. But we need to leak libc address, so we need to still do the PLT thing. That's fine. I mean, this is a pretty good repeat of the stuff that we did the last time. So can do pattern search for 4069C. I think 4069C. Oh, wait. So 4069C is the like address of the return instruction in main. When you're saying do pattern search for that, so let me generate the pattern again because I don't think I have it in my clipboard anymore. And we run it, and I do pattern search and give the address of where I'm currently at. Yeah, so it's just searching for some text within the pattern, right? And so I have to copy out the text that was put on the stack instead. Or, you know, happens to fall at where the stack pointer is pointing at that moment that we do the return. Okay, so first thing we want to do is get our binary. Oh, okay, yeah, PETA might have that feature where it's like we know what we can look for. How to say it? Yeah, I don't know. That'd be cool if that worked, because it would be a little more straightforward than me finding it in the register. But it's not that much additional work, I guess. Really, what I'm looking to move towards after this is pwn debug. Probably, it just feels like that might have more energy around the ongoing development of it. So I'm not putting a lot of effort into getting good at Jeff, and I think I will switch over to pwn debug at some point and see if I prefer that. If not, maybe I'll switch back to Jeff or check out PETA. I used PETA for a little bit on some random thing that I was doing, and it seemed fine, but I hadn't put a lot of time into learning the features of it, really. I'm looking at it as like, well, it prints out all of this stuff, which is nicer than bare GDB. Oh, it's way better? Okay, so yeah, I'll just switch to pwn debug and then put my efforts into learning how to be really effective with that, I think. Because all of these are definitely a step up from me just using bare GDB and typing in commands all the time to look at the stack and look at the disassembly and all that stuff. So, but there's certainly way more to it than just it prints out stuff for me. So we are going to just straight up load the binary and find the puts PLT address with binary dot symbols and the GOT address, and then we can use one gadget on this path. It's the same path as it's always been, but never hurts to run it again. We're using this third gadget because that's the one with the constraint that we can pass when we're at that main function return. So that's all good. And our gadget is going to be this address. And we'll need a pop RDI. in order to do the PLT, GOT trickiness. Pull that out. Oops. Okay, then where do we want to go? We need the main start address. So let's just do it in GDB. I guess I probably could have just typed in main or something and it would print out that address for me. Do I want to leave these as long as whatever? I don't care. I guess, yeah, it doesn't matter because I'm going to use pack 64 on it. Okay, I think I might have everything I need to run through it through the main function one time, overflow to leak the address of the puts function, calculate. I'm going to be lazy and what was the one I was just working on? It was called FB19 over float. Gonna steal my puts offset value from the previous challenge. Oh, thanks for the follow. Yeah, I am definitely gonna try to live stream every day. I have managed to do that for the last 4 days, I think. So it's usually just, you know, maybe 2 to 3 hours. I get through 1 or 2 challenges in that time. Or, I mean, now that I'm going to switch over to format strings, which I have a lot less experience with, you know, maybe I won't even get through a single challenge in one of these sessions, but I do try to start my day off with some streaming. This is actually, I'm in Thailand at the moment, so it's like 2 p.m. right now. I got started a little bit late today, but I usually try to start streaming around 9 o'clock or something. Oh yeah, I could just get the main address with binary. That is smart. I need to think about the tools that I have. I can do I functions. Oh yeah. I func. There we go. Okay, cool. Thank you. I'm appreciating these tips. Oh, there's more going on. I see these are, you know, not library functions, and the fact that it's called story time, there's a beginning, middle, climax, and end. So maybe we have to do more than just overflow that buffer and get everything going. I don't know. I'm gonna try it without even having reversed it in Radar or anything, done any real static analysis on it, and we'll see if I can pop a shell from this. If I can't, then I'll probably have to call at the end of this stream, because again, I've got something coming up in like half an hour, 40 minutes, or at least I'll have to end the stream by then. So I don't want to dive into a much more complicated challenge if this straightforward approach doesn't work. But that was unexpected, that there's a series of additional functions that I don't know if we were actually executing them when we were running through the stuff that we just did. I guess whatever my inputs were didn't trigger any of these write calls and stuff, so I don't know. I'm gonna not worry about it for now and hope that I don't have to worry about it. Okay, and then we've got the offset for libc, and obviously I could use call elf and get it from the symbols of the libc file, which is actually how I got this number in the first place. I just did it in Python REPL instead of put it in the Pwn Tools script. I don't know. I don't know why I do some things the way that I do them sometimes. Okay, so now I feel like I probably do actually have everything I need. I'm going to say prefix len is 50. I think it's 56. I think the output from that's a good question, actually. The output from the pattern search, when we did it up here, and it said, is it further up, I think, and it said found at offset 56. Does this mean that it says it did a big endian search? I don't know if that matters. The fact that it found the same offset makes me feel like whatever it did correctly. I'm not on a big endian architecture, but or maybe it's just doing it as a big endian search because these are individual bytes, so it's going to be looking for it in that way. That makes more sense. Yeah, I don't know if the H is byte 56 or there are 56 bytes prior to the H. I'm going to say H is at offset 56, so I need 55 bytes of prefix. And cool. Then I guess we can do this in the traditional, like, set up a payload string, where it's just going to be equal to let's just do the traditional A's, encode that into bytes, and what else do we want? Then we are going to do our wrap chain. Yeah, I'll just do it manually. Plus equals P64 of pop RDI, P64 of puts GOT, and then we also want the main address. Okay, so we're gonna pop the GOT address into RDI, then call puts from the PLT. Then when that finishes, we will return back to main. We need to, I haven't done any of the actual input-output stuff. So before we send, oh, I haven't even opened the process. And this is like, oops. Let's call this payload is payload leak. Okay. And we'll receive until colon and the new line. And then I think I need to say send line. I think it's waiting for a new line to be entered. Might be a gets or something. So do the leak payload. And then we need to, it's not gonna print anything else, I think. Because if I, oops, just do like then yeah, it doesn't print anything after that. So we will say libc puts adder as bytes is target dot receive until a new line character, drop is true, and then for I in range 8 minus len libc puts adder b. So what I'm doing here is do everything with double quotes. Just padding out the end of it. I don't think you can do like right justify, L justify, whatever the fancy like string helper functions are, because it's a bytes thing. So I'm just appending on individual null bytes until we've got the 8-byte value so that we can unpack it. Okay, so now we know the address of libc puts. Libc base is and we can say libc gadget is libc base plus gadget, I guess. My naming is pretty unfortunate because I'm just going through this as quickly as possible. So now we are back at the beginning of main. We'll receive until the prompt again, and let's say payload shell is the same and then it's just the libc gadget. Okay. That feels right, but I don't give it a high likelihood of working. None of these have worked on the first try, so I'll be pretty surprised if it does. And especially with this being the last challenge in this set, and they have been, in theory, getting harder with each one, I kind of would be surprised if this was like the most straightforward of the dynamic ROP kind of challenges, but let's find out. What doesn't have... Oh, well, that'll be... Okay, fair enough. I don't know what symbols we have in the GOT. I was just sort of assuming it because all the previous ones did, but they could just be calling printf, I guess. I don't know. We'll find out. Let's see. Try binary.plt. Okay. I didn't know that PLT was even a thing. The previous example that I was working from, where they used this technique in one of the walkthroughs, and that's how I learned about it, was just calling binary like dot symbols. But it's not in either of those, so let's do print binary.plt. Can I just get that like whole thing? So it's got read and write, and maybe that's why this becomes more challenging. So if we only have read and write, can I should just be able to write, but I need to pass other arguments for write. It's going to be in page 2. So I need to put 0 into RDI. I need to put the GOT address into RSI, and then the count of 8 into RDX, I guess, if I'm remembering my 64-bit calling convention correctly. So, okay. Let's see if we've got the right pops for that. The right gadgets. We have an RSI and a pop R15. I don't think I care about the R15 being there, so that's fine. And then nothing for RDX. shit. How can I get a size value? Why don't we see what is in RDI when we get to the return? Didn't I have like... Okay. So, or not RDI, but RDX. RDX is 190. We can write more than we need to and just take the first 8 bytes, I guess. That should be fine. I don't think I need to worry about that. Let me double check that I am not misremembering. That it goes RDI, RSI, RDX, RCX. Yep, okay. So that's fine. I'm going to leave RDX as it is. And we'll clobber R15, and I don't care. Should have copied the whole thing. Okay, so we need the address of write. And now I'm going to do this as libc. Where did I do it? With one. Pull this out. Okay. So then libc write offset is going to be libc dot symbols and our gadget will be the same. I don't know why I'm bothering to rearrange this stuff, but it just feels right. Okay, so now our leak needs to be, we can, oops. We're going to do 0 so that when we write to standard out. So that'll be an RDI. Then we will pop RSI, and we will need, we'll pop 0 into R15, and then RSI is going to be the address of write. Then we will call write, and we'll reuse the existing value of RDX to do so. And then when write is done, we'll go into main again. And let's see. We'll get that address, and now write is not going to give us a /n. So I need to remember, we're not going to receive until, we're going to receive a fixed number of bytes, I think, and that will be good enough. Receive n, okay. And that's going to be just 8. Yeah, okay. So we'll receive 8 bytes. Don't need to pad it anymore. In fact, we can probably, no. I'm so bad at Vim. I need to improve those Vim skills a little bit. Okay, so we'll just receive the first 8 bytes. That should be the address leak. And I'm even less confident that this is going to work, but only one way to find out what is going on. Okay, we were in receive until on line 34, the first one. Is it like space and then a /n? Okay. And that was end of file on that receive. Interesting. So let me fix this one first. Did we get a crash when we did that? Presumably the write call didn't happen. Oh, I didn't mean to run it again. Okay, let us print, or not. No, I don't want the repr version. Okay, we'll get our exit.exe, and now I'll just pass that into GDB. I know you'll probably mention that there's a way to do like attach from pwn_debug or pwn_tools. I can attach GDB. I still haven't figured out, and maybe you can help me if you know this off the top of your head. So I'm like just SSH'd into a VM where I'm running all this stuff, and it seems like when you do GDB attach, it wants to spawn a new shell. Like it started a new xterm for the people that I've seen use it just on their desktop, and I don't know how to get it to like do something that's appropriate for my circumstance where I'm SSH'd in. So if you happen to know, let me, feel free to share that in chat. But I haven't really put any effort into figuring that out because I can just print out my input and then run it like this. And I'm gonna break on the end of main. Can do pause after payload leak and then GDP attach in the PID. And that will put the GDB session in the same terminal instance that pwn tools is running in. Let's give it a shot. Take this stuff out for now. And let's see. So we were having an issue here. Target.pause, I guess. Target, and then I can do gdb.attach target, I think. Like that. No. There's no pause. Is this like just straight up? Oh, I see. And then I just I don't GDB attach from here. I GDB attach on the other terminal. That makes sense. Okay, let's do that. Do I put -p? I don't remember. What's the PID? 5.2. Oops. What did I must have hit a key in there. Okay. 5246. Cannot attach. What? Why not? Oh, I have to fix ptrace scope. Okay. 2 or 0. Didn't like that either. All processes can be debugged. 0. So double check that it's the value that I wanted. Okay. So why can I not? Maybe I'm using the -p incorrectly. No, that seems fine. 50246. Oh, it's already terminated. So it's just quitting out after sending the payload. If you have any suggestions, I would certainly be curious, but I don't know how to break before the program quits. Right. Yeah, I can use GDB attach PID inside of, like, for example, I mean, it's closed now, but so it's not going to work. But I think, let's give it a shot. I'm still getting the same issue where I can't attach to that process because it's actually already exited. As soon as we do the send line, it runs, it overrides the buffer, and could we, okay, that's one thing that I can do. I don't have to send a line. So we can send that stuff, we'll pause, and then we will send empty. I do like put the pause here, but the program, or I mean, like here before we actually send it, even let the receive happen. I can do that, but oh, I see what you're saying. Okay. Because then if I'm attached when it crashes, sure. Okay, that makes sense. Thank you. Okay, and then unpause. Why is it not unpausing? Oh, because I need to say continue. Okay, and now we've segfaulted. And I want to, I don't know why. Okay, so we're going to do this. We're going to pause before anything has happened. I want to actually put the breakpoint on the end of main though, because obviously we're segfaulting, something's happening, but I'm going to just sit at the return and then step through what should be running the little ROP chain that I built. Think, is that the right address? Yeah, okay. So we will find out if it has actually done that when we hit continue. Let me just start GDB again. Do this from blank. Throw the breakpoint on there and then continue. Unpause. Now we hit the return. And what do we have in RSP? Okay, it's got 4007. So we go one instruction. Can't disassemble this stuff, so that's interesting. Am I putting the wrong address in there for the ROP gadget? Or maybe I'm not writing it far enough. Yeah, because it should be another byte after this, I think. Okay, I think I need to put one more byte in the prefix, because that pop RDI has an 03 after it. Dare I take out the pause? Let's try it. No. Okay. Just hubris on my part to be like, oh, maybe that was everything I needed to do. Let's run it. Okay. Oh, now I have logged out. I think I hit Control D or something too many times. Practice. HS. Okay. And then attach to 5360. Throw the breakpoint on there. Continue. Unpause. Now we hit the breakpoint. Now we've got our pop RDI. Okay. And what are we going to pop into RDI? RDI has 0 in it. Not. Yeah, that's what we wanted. Okay. What are we going to pop into RSI? RSI has that address, which will have that value for the write function. Sounds good to me. And R15 has 0. That's fine. And now, where are we returning to? We're returning to the PLT stub for write, I assume. And it should have called write already. And now we are at write. So when we hit finish, okay, it's basically working. But so write does its thing. Maybe it printed somewhere and I can see it in here. I don't know. I'm not seeing the output from write, but let's assume that it actually did it, because I might still be calling that incorrectly. But what's then happening is we run through the main function again, and it calls read, but we haven't sent more input, so we need to. How to do that? You can Control L on GDB to get rid of the text when you are attaching again. Control L? Oh, just that's like clearing the screen. Okay, good to know. So I think we ran through. Did I have that? I don't know. We ran through the main function again, and did we not? I feel like we did. And now we are going to return to just nowhere. Is that address from something? So I hit finish to end the write call, which is interesting that this climax function is on the stack. Again, that might be coming into play, and I'm getting dangerously close to having to end the stream, but I just feel like I'm so close to having this worked out. So we're going to put the main address again as where right will return to. So why don't I run this again, attach to 5497, put a breakpoint on the beginning of main as well, so that when we return to it from right, we should hit that, and then we'll see what's going on. Okay, do those pops, get into the right function, hit finish. Now we're at the beginning of main. Okay, I did not see anything. Maybe it doesn't print in GDB because it's been consumed in Pwn Tools. So I'm just gonna do that. Oh, whatever. We'll continue. It's gonna hit the breakpoint of the return and then segfault. So what I want to do is print libc base, just to like have something coming out of Pwn Tools to make sure that this stuff has happened. Because should be able to do that stuff again. Log.info in Pwn Tools. Okay. And I think we've got our breakpoints in place, so I'm going to unpause, get to the return. Just going to hit continue because we know what that does now. And we got to we got back to main, but the right didn't write anything. So maybe that's the issue. Oh, no, there we go. We wrote this, but that does not seem like a valid address for where that, yeah, that doesn't seem right at all. What are we getting from, oops. Sorry about that. Okay, let's see. We're doing that, which should write the address of the right function wherever it's been loaded along with libc. And it doesn't seem like it would have, I mean, maybe that's, let me print it as not hex. It didn't look like it was exactly all ASCII, but maybe it was. Yeah. Okay. Let's just do it without attaching. It was all numbers. That's interesting. Was that the case before? It looked like 57, 50, 20, like we're just getting gibberish out of it? No, it's the same value each time, which is also worrying because it should not be the same value. Okay, this is what we want to do, actually. And then we want to lock that out. Okay, so the write call is not happening. And we're just reading in the stuff that's printed out from the repeat to main. So the write call is not doing what we want it to do. It's not writing to, I mean, file descriptor 0 is right, when we're calling write over here. Oh no, 0 is standard in. This is me being dumb. Okay. Ooh boy. So close and yet so far this whole time. Alright, still not quite right, but we're getting that address. And take out those info logs. I'll run it with the pause in there and 5551. We'll continue. Unpause. And then if we're getting an address like this, and yeah, I've definitely learned several new things from you. Thank you very much. I was going to say that a little bit later, but I can definitely say it now. Thank you. Help me pronounce your name. Is it Fernicarol? Fernicarol? I don't know, but I really appreciate the tips because I unfortunately don't spend as much time as I really should digging into the best way to use the tools that I am working with and how to get the most out of them. So just, you sitting here and being like, oh, you should do this, or you could do this, really helps me. So, or Julian. Okay. Nice to meet you, Julian. My name is Charles, so you can call me Charles or Hamlet. It's all good. Okay. So we are leaking the address of write, and then we should be calculating. So why didn't we, so this is the pop, okay, and then we are back to the beginning of main, and now when we get to this, where are we going to continue through? Which is nothing, right? This is null bytes here. Pretty sure. So, and presumably, yeah, that's going to segfold immediately. Okay, so we are still not calculating the right address for the gadget. Yeah, I don't see why that's happening. So let's infolog libc. We could even say and then log what we think the gadget address should be. Yeah, we could definitely go for just the more traditional setup, but I think if I'm going to do that, I'm going to have to do that on the next stream. Because if I can't figure this out in like the next 4 minutes or so, not going to have any success with it. What did I do? Log.info. Yeah. Okay, so this is our base for libc. This is the gadget address. Why are we not returning to that? Why is that not what we have? Something is off in us sending the second payload. So let's look at the stack. Since you're on a delay, I'll ask you before I get to that point. What's the easy way in Jeff, if you remember, or maybe what you would do in PETA, to just say like print out a lot more of the stack than what we're currently seeing? Because we're like off of RBP here, pretty sure. Or are we off of RSP? I guess we're off of RSP, so I should be able to see all of the prefix and then the address that I anticipate having. But yeah, if you know of any commands to just like show me more of the stack, because that has come up a few times and I've just had to like do examine memory and stuff. Okay. Just, yeah, okay. That's fine. I wasn't sure if there was just a like thing to say, hey, just expand this window on the next time you print stuff, but I don't know. I'm used to, more GUI tools like a cheat engine or something where you can sort of get more visibility pretty easily through that. Okay, now when we get back to the return, our desired address is nowhere on the, like we haven't overflowed the stack somehow the second time. What is going on with that? We just did a read. We did a read into RBP minus 30 hex. So let's do 48 bytes at, or let's do, 64 bytes at, and this, tell me how to do this better, because I try to do like RBP minus 30. Okay, I need to, no, I don't know how to tell it, like, use this as the address. So RBP has already been overwritten, so I can't actually get that. I need to put that's the issue. So what do we think RBP would have been? It's just going to be what RSP is now. I'm going to do minus 30 from, so RBP minus 30 is RSP. RSP plus 30 then. Maybe we can see, or just add RSP. I'm not seeing my overflow. Okay, I don't, It's gonna be late. What am I doing wrong here? Start main again, it writes that stuff, and then it should read into the same buffer. We're giving it 56 A's to overflow, but it hasn't overflown, or it's overflowing weirdly. I guess it's overflowing. It's not overflowing because the... I thought so. Oh, Jesus Christ. No, still wasn't enough, but definitely I need to plus equals onto the end of the shell payload. So that's fun. All right. Attach 5596 and then continue to this ret, and now we are going to jump into the address that we think we're going to jump into. So cool. Okay, and then we get a seg fault on the, oh, this is interesting. I didn't think that we would be able to trigger this when we weren't calling system directly, but I guess we're jumping into the middle of the do system function, so that causes it. So I don't use Python 3 for pwn. Yeah, so I can show you what will happen if I take off the encode. I'll do it on the first one, I guess. Then we can't add the bytes that comes back from packing a number, because what we get when we multiply the string by some number of digits is just a string object. So we need to first encode it as a sequence of bytes, and then we can append additional bytes to it. So that is one of the things that you just have to sort of live with Python 3. And I think I've worked out all the places where I start needing to write encode and might not have had to do it before. Okay, so we need to pop two things. So thankfully our pop RSI has that already. And we can just pop 2 zeros, I think. So I don't think we need to worry about RSI. So the issue that I'm dealing with, I've seen this several times at this point. If you get to a seg fault on this move APS instruction, depends on which exact distro of Linux you're using, but basically move APS will seg fault if your stack is not 16 byte aligned, and our stack is 8 byte aligned currently. So if I pop two things and then return, that has an offset to the stack pointer of 8 bytes. So just do this gadget first. That'll align our stack properly so that when we return into the system like shell popping gadget, it should not seg fault. And it still does. So I don't know what I am doing wrong at this point. Oh, because I am adding it to the leak one. Come on. Oops. Wait. Is this enough? No. Sig abort. Okay, interesting. This might be where we get into the additional challenge of the program. So I'm gonna take off those breakpoints because I don't think we need that anymore. Gonna run the exploit, attach to it in GDB, and continue, and then we get to sig abort. Coming out of, we got a raise from cannot access memory at that address. What in the Okay, well, I'm not in a position, I don't have the time to investigate what's going on, why we are getting... Oh, these are issues from GDB. It doesn't know how to access that memory, but I don't know why we're getting into this, why we're getting a signal, I guess, from why abort is being called at all, frankly. That might be from one of those other functions. I don't know. At the same time, abort wasn't in the PLT, so maybe they've written a syscall directly into one of those functions and it's got some trickiness, or maybe I'm just doing the shell popping stuff incorrectly still. So that is something that I'll have to figure out on the next stream. Thank you very much, Julian, for joining me, and whoever else popped in the last 30 minutes or so. Yeah, I'm going to try to stream again tomorrow. It'll probably be, it's 3 p.m. here, so let's say 5 hours prior to whatever time it is in your time zone right now, 5 or 6 hours. Will probably be around when I start the stream, 9 to 10 a.m. my time, and hopefully we'll get this solved real quick, and then we can move on to format vulnerabilities, printf with %n stuff, I think. So again, thank you very much for joining. I'm going to have to cut it real short because I have a Zoom meeting call to get onto. All right, I'm just sort of vamping so that the stream will cut off in the middle of my sentence, I guess.